Hi everyone, and welcome to our video on the introduction to the average rates of change. So a rate is something per something. So it doesn't matter what those somethings are. So often when we are driving in miles per hour is our speed. So distance per time. So this second one is often involving time. So like profit could be dollars per month or cost dollars per month. It's really anything per anything or something per something. But let's break down the visual of it and look at it mathematically as well. So the average rate of change, which we'll usually say is AROC for abbreviated, measures an average change in a function from x1 to x2. So we have a formula, and one thing we want to note out of it is, well, if we remember some algebra, remember the slope is the same thing as y2 minus y1 over x2 minus x1. That's what this first one is. Okay, so an average rate of change is really a slope. And so if we have a function, but it is a special kind of slope. So say I have a function, I'm just going to draw some kind of curve like that. So here's our function y equals f of x. And if I want to know the average rate of change from this point to this point, well, this is my first point to the left. So I'm going to say that that's x1 comma y1. And this is my second point to the right. So I'm going to call that x2 comma y2. And then the line connecting these two dots is what's called the secant line. Okay, so this is the secant line in blue. But the slope of this secant line matches the equation up there. So sometimes we say, we'll do slope of secant line. So a secant line is just going through 2 points on some random function, just like this. So just like this visual. Slope of secant line, which we're going to say is m with a little subscript secant, is the same thing as the average rate of change still, because it's still a slope. It's still the same formula up there. So the y2 minus y1 over x2 minus x1. Okay, and so to get our slope, the other way to look at it is using this function notation, so to the right there. Well, remember with functions, if you plug an x value in, you eventually get a y value. So for instance, like if I were to do f of 2, whatever this is for whatever function, that's a y value. So there's an x value and there's a y value. Okay, however, this whole thing is that same y value. Okay, so x is just the 2, y is the f of 2. So what I'm trying to break down is in each of these points, this y1 is the same thing as f of x1. This y2 is the same thing as f of x2. And so we could say, well, our average rate of change, still our y2 is the same thing as f of x2, so we put it here, minus our y1, which is the same thing as f of x1, over the x2 minus x1. So there's where the second equation comes from. Okay, so but the main thing I would think is just try to think of it as just a regular old slope. And sometimes we need to actually evaluate those top parts. But for this first example, let's look at a table. So they'll make us do average rate of change problems in different ways. So here we've got a table problem. So in this example, it says, I drove to Reno from Mina, or Mina, I don't know how to say it. It's a really small town. Okay, so in Nevada, so if you want to look it up, it's like population 100. Okay, so I drove to Reno from Mina and recorded my distance traveled in miles every 0.5 hours in the table. Okay, so we've got 0, 0.5, 1, 1.5. Okay, so we can see that, and then the distances are here. And then it's asking, what was my trip's average velocity? Okay, so velocity, so instantly we have new vocabulary. So it does say average. However, velocity here, so remember we're looking at a rate. A velocity is some distance over time. So velocity is a distance over time. And so if I'm in a car, our unit would be miles per hour. And so now we're back to the top of the page where we said, oh, anytime you have a per, it's a rate. Okay, so this is the same thing as an average rate of change. It's just it's specific for velocity. Okay, so this here still is, block that all off. So this is an average rate of change because velocity is a rate. Average rate of change. All right, so to do this one, let's keep it in the black ink. It says, what was my trip's average velocity or average rate of change? All right, so I'm going to mark the top here. Here's our x1. That's the first value in the whole x values of on my trip. And then it says, what was my trip's average velocity? So I'm looking at the whole trip. And so I'm going to put x2 over there, which instantly means this is y1. So it's connected to x1. And then this is y2 because it's connected to x2. And so we can find our average velocity then. So we're going to do it like this. I'm still going to do average rate of change. And we'll just set it up, y2 minus y1 over x2 minus x1. And then we'll plug those in. Okay, so y2 is 190 minus y1, which is 0, over x2, which is 3, minus x1, which is 0. And then now we would do the subtraction. So these would have implied parentheses, the ones that I'm putting right there. So we would do that first if there was something besides 0 that was more important. So we will just simplify to make this 190 divided by 3. And then often they want to make it as a decimal. Okay, so this might be fine, but in applications, we usually don't say fractions like this. Okay, so we could plug this into our calculator, and we would get 63.33 miles per hour. I'm going to do it like that. Okay, and whatever they want you to round to is fine. Okay, so I did 2 decimals. Okay, and so it's miles per hour. Okay, because our y is involving distance, so that's miles, and our x was involving time, which we're doing in hours in this problem. Okay, and then now let's try this number 2. So it's asking, what was my average speed between 1.5 and 2 hours? Okay, so I'm going to do this one in blue. So 1.5 and 2 hours. So that's the x1 and that's the x2 in this case. So I have 1.5, and mark that in blue, and 2. There we go. So there's my x1 and x2. And then instantly connecting, that would be the y1 and that would be the y2. And so our average velocity, and notice they're using speed now, so a different kind of just the synonym for velocity. Okay, so average speed. Still, I'm just going to do average rate of change. And then now we'll plug those. Let's actually write the formula out still. So there's our y2 minus y1 over x2 minus x1. And then we can plug these in. Okay, so x2, actually let's do the top first. y2 is 130. y1 is 90, so minus 90. And then x2 is 2. And then x1 is 1.5. Okay, and then now we would do this, again, the parentheses are there, so 130 minus 90 is 40. And then 2 minus 1.5 would be 0.5. And then, again, we could use a calculator and plug this in as needed. This will turn into 80. And let's change our notation. I'm going to do miles per hour. Okay, so just to mix it up. Okay, so it looks like in that half hour, driving a little bit above the speed limit somewhere. All right, so that's it though. Okay, so that was our average speed between that 1.5 and 2 hours. Okay, so that's how we can break down the average rate of change. So it's really just slope. So you think, oh, I could do slope. So instantly you could also say this is the same thing as m and use your slope equation. Okay, so it doesn't matter really the notation here. I would say what's most important for a final answer is making sure you got your number and your units. If you wanted to do like velocity instead of average velocity, instead of average rate of change, then we could just do like v. Okay, so you could do different letters just to point that out. Okay, but that's it. Thanks for watching, and I'll see you again next time.